Hi, good evening, all of you. Hope you are able to view me. Hope you are able to see me. Hope you are able to get my voice. Can you just confirm in the chat that yes, you are able to view me? You are get yeah, it's everything is clear, connection is clear, so that I can start our today's discussion. Am I audible to all of you? Am I audible to all of you? Yeah, I think Mr. Srinath Pandey confirmed that. Yes. Thank you, Srinath. Yeah, thank you, Mr. Sumit Sharma. Thank you so much for confirming that. Yes, I am audible and everything is going well. So, let us start our today's discussion on HMI, PLC, and SCADA. There are a lot of problems with respect to the discussion on this topic. So, we are discussing today. So, start with this discussion on HMI, PLC, and SCADA. So basically, why we are discussing, the reason is in future, even now so many companies already started using the automation in their pharmaceutical industries. About 10 days before or 15 days before, we had a discussion on pharma 4.0 concept, and now so many companies are now moving for automation. So basically HMI, already so many company machines are having the HMI screens and all. It's a initial stage of the automation, you can say. Then why the people are going for PLC, and now why the people are moving further for SCADA approach, that we are going to discuss today. So basically we this training is to make you aware, make you understand the differences and expect and what are the requirements for HMI, PLC, and SCADA. Everything we will discuss today. So let us discuss about the agenda of today's discussion topic. So there will be the brief introduction about the topic and scope in the pharmaceutical industry. A couple of slides about the know your trainer. Why I am putting this know your trainer slides? Because many companies put this training session as their internal training to all the team members, so and they record as an external trainer. So as a requirement, if it is an external training, the CV of the trainer should be there. So I am putting as a part of this session only, so that they can record this as their external training for their companies. We will discuss briefly about the HMI, industrial uses of HMI. What are the industrial uses of HMI? What are the benefits of HMI? HMI means human machine interface. Brief understanding of a PLC. Then once we discuss about the HMI, then what is the basis of PLC? So why initial phase is a HMI, then upgradation version is a PLC. So we will discuss about the PLC. Then most of the machines are operated with the PLC. So that is the reason I put one slide about the major considerations of URS in PLCs, what specific we need to consider. Along with, of course, the requirements will be more and more, but the basic requirements about 5-6 I collected where many companies lack, that I put here. After using the PLC, which is the upgraded version of a HMI, what are their drawbacks again still with the PLCs, that we will discuss. Of course there are benefits, so we are going from HMI to PLC, but still there are some drawbacks with the PLC. So that is the reason we need to have a next version of upgradation, that is called SCADA. So we will discuss about the SCADA, what are the components of the SCADA, and after that there will be a question answer session. So I suggest you put your questions in the chat box. I will go through the questions, all the questions at the end of the session, and after that we will discuss about the each question. Okay, and hope I am audible to all of you and everything is okay. So this is just a brief about the know your trainer. My name is Hitendra Kumar Shah. I am a CGMP compliance consultant, trainer and auditor from NADH plus GXP compliance services. I am having more than 23 years of experience, and this is the brief about my CV. I don't want to put more focus on this. Anyone is interested, they can stop the video and they can go through this about my, the information about my CV and all. I work in different companies. I started my career with Sun Pharma. I work in Blue Cross Laboratories. I was taking care of validation in Alembic Pharma. Then I work in Usage of Scada as a compliance head. I work in a quality head as a USV. Then I work in AstraZeneca, Sanofi, Mylan. These are some companies I work. Since last five and a half year, I am independent compliance consultant, trainer and auditor from NADH plus GXP compliance services. A brief disclaimer about this thing I am putting here, this training session I am putting here, because the point is this is basically I am preparing for the learning purpose to all of you. Okay, so what happened, if you want to implement and all, you can definitely contact me, no problem, I will support you. But when we discuss about the implementation phase, then it varies from company to company, equipment to equipment, facility to facility, and practices to practices. So many differences are there. Some implementation will be better for in one company, that may not be suitable for another company. So as I am discussing on all the different topics like validations, data integrity, documentations, and so many topics. So this is another topic about HMI and all. So my point is, you consider this as the overall learning purpose only. I collected all the information from different guidelines, websites and all, and I prepared this. Okay. So this is just a disclaimer to all of you. And now let us start with our today's discussion on HMI. HMI means human machine interface. Everybody may be aware about this. Okay. Everybody will be aware about this. One more point I just want to touch upon, because I am changing the slide, but it will take some delay. It will take some 10 seconds or 15 seconds to appear on the screen. So be patient. There is a somewhat delay. Okay. So now HMI, okay, human machine interface. Okay. So what is meant by this? It's a simple screen. It's simple a screen where you can operate. Very simple. And whatever I collected this, I prepared this presentation. If you are interested in presentation, you just confirm me. I will share a link in the chat box, and from the link you will able to download it. But the link will expire in just 2-3 days, so you immediately download it so that the link will not get expired. So why I'm telling this, because whatever the content I took it from so many IT references and all. The wordings will be more with respect to IT, but I try to make it in a simple form. It is very easy to understandable to all of the people. So that is the reason, if you are interested, I will share it, no problem. Words are very clear in the slide. Line operators, managers, supervisors in industry rely on HMI to translate complex data into useful information. So what happened, most of the machines, means now I am discussing about the traditional machines, okay, not a current available existing machines. The traditional machines, they are operated through the HMI. So in the HMI there will be some options like on and off, or some temperature record. It is displayed, temperature this, humidity this, so it will be displayed. So they use HMI to monitor the machinery to make sure it is working properly. Means traditionally the use of the HMI is just like a switch, on and off button or something monitoring, that's it. Hope you are getting my point. HMI is only the screen which is only displaying what is available. For example, now this is a screen of the computer, and whatever I am presenting, that is only displayed on your computers, correct? Computers, or your laptops or the mobile interface. So whatever data I am presenting, that is only displayed on your screen. So this is the similar way HMI functions, simple way. So basically HMI is just to function some limited parameters like on and off, or to monitor the temperature of the of the process or equipment, or a specific reaction. So that particular things can be monitored by the HMI. Very simple in the language. Okay. Hope you are getting my point. Again, I am telling, if you have any questions, don't worry. You put your questions in the chat box or comment section. I will read all the questions at the end with the name of the people who are putting the comment, and I will reply to you. Okay. So what are the uses of HMI in industry? So it depends on different requirements of the different machine to machine or users to users. For example, sometimes it is used to visually display the data. Sometimes it is used to display the data, and it will be a visual, so that the like inside reaction temperature is suppose 70 degrees. So you need not go and insert the thermometer inside continuously and monitor the temperature. What you need to do, if you put the sensor and connect with the HMI, you can from the HMI you can see the temperature. So that is a visually displaying the data. Track production time, trends and tags. So you can track the production time. So when you put on, there is timing that start date, put off, there will be machine off date or stop date, time, so that from the basis of timing and all, you can evaluate the production line and all. But here point is, here I have mentioned track production time, trends and tags. So basically you can track the time, but trending and all will not be possible. You have to manually trend. For example, in first of the batch, it took a reaction for suppose 4 hours. In second batch, it shows the reaction time. Okay, it will show only the reaction time. The reaction time will be 4.5 hours. Third batch, it will display the reaction time as 5 hours. So the trending you have to do manually. It will not analyze it. Okay. Oversee the KPI. Most of the time, the KPIs will be, to control the operations within a stipulated period and all. So it oversee the KPI. Monitor machine inputs and outputs. So it monitors basically machine inputs and output based on the different sensors connected in the machine, like redox or some different type of sensors who monitor the oxidation reduction potential in the reaction, temperature or any other parameter which will indirectly correlated with the output. So that way you can monitor the machine input and output. There are so many different type of uses of HMI. So I preferred these 3-4 point to make you aware about the basic requirement or basic uses of the HMI. Okay. Now I am putting the here point PLC. I am discussing now what HMI, but frontly, in this slide I put purposely the correlation with the PLC. The reason is, they are very close to each other. That is the reason I just want to put and make you aware about the things. So HMI communicate with the PLC. PLC means programmable logic controllers and input output sensors to get and display information for users to view. The point is, when HMI is the earlier old version. Now the point is, on the PLC, whatever the screen is there, many people call that screen as a HMI, because the screen of the PLC is also used to put the input output variables or to program in that, right? And this is a human machine interface. So many people refer the screen of a PLC as a HMI. So I am just making the clear about the concepts. Okay. HMI screens can be used for a single function. See, this point very important. I am discussing about HMI, not PLC, but I am just clarifying about the concepts or terminologies. So please understand this, and please be with me up to the end of this session. But because this type of training I could not find anywhere else, so that is the reason I purposely prepared this. HMI screens can be used for a single purpose or single function, like monitoring, tracking, or for performing more sophisticated operations like switching machine off or increasing production speed, depending on how they are implemented. Simple example I will tell you. Means, suppose there is a HMI, one HMI, the one key will be there in the HMI to run the machine. That's it. The another button will be for when you push it, press the button, speed will be increased 50%, 60%, whatever, in terms of the different units, it will increase the speed or reduce the speed. So that way you will able to do the operations. Now what is the benefit? The benefit is, instead of putting on and off manually, or instead of putting some different machines or different buttons to increase the speed or tracking the things, you can just work on the screen. This is a more easy to operate the machine. So that is the reason HMI is used in many companies. But the problem is then it is used only for some single functions, not a multiple functions. Okay, hope you are getting my point. And just keep this point open. If you are not understanding also single function, multiple functions, keep this point open, because while discussion of the PLC, again I will discuss the same example. Okay, don't worry about that. So what I was telling here is the HMI. What is the name of, what is the HMI, what are their uses, and what is the use of the HMI in the industry. There are some benefits of HMI. So basically, due to HMI, there is an enhanced visibility. Enhanced visibility means what happened? Like suppose if there is a reaction and you have to monitor the temperature. Temperature is increasing from 20 degrees to like 30, 40, 100, 120, 150 degrees. So you need not go and monitor the temperature in the reactor. You need not put the thermometer and all. What you can do, you can just monitor the HMI, and from there you will able to view the increase in the temperature. So it enhances the visibility, increase the efficiency. So as it is very much friendly to the operators and all, it increases the efficiency of all the overall functioning. Decrease downtime. So if there is some adverse observation, like if suppose the temperature should reach up to 150 degrees, but the temperature is not increasing up to 150 degrees, and there is only the temperature is maintained at 100 degrees, not increasing, immediately the operator will come to know, and immediately the problem will get rectified. So this type of problems will be viewed if it is monitored continuously. So that is the way it decreases the downtime. It is used because the benefit is it improves the usability also, and it is a unified system. So basically, it is a unified system. Unified system is basically, it is a, you can say the data center position, data centric. So basically what happened, like computer, it is having a separate parts, So this is the unified system. So the unified system means, it's a you can say the how I can explain you, the data center, like data is getting collected. Okay, it is in some computerized system. It is collected, then it is computed, and then it is displayed, and then if it is connected to some network, it is getting transferred to the network. So this type of system is called a unified system. So the HMI can very much used as a unified system in the different companies. Okay, hope you are getting my point. If you have any questions, don't worry. Okay, I will contact. I will I will reply you at the end of the session. Now I told you about the HMI uses and all. Now let me discuss about the PLC. Okay, let me discuss about the PLC. So PLC long form, okay, we know that programmable logic controller is an industrial computer control system that continuously monitor the state of input devices and, see this word, makes the decision. So PLC makes the decision based on a custom program to control the state of output devices. For example, PLC of the machines. I will give one example so that you will understand in a better way. Suppose you want to I was telling about the HMI, right? That it is useful only for one function. That is, it is used for only either monitoring function or controlling function, right? But PLC, what it does, it is connected through the, of course, HMI, but PLC, the main is it is having based on the logic. We give some program to the PLC so that what happen, whatever data is collected, it is monitored, and based on data the program will be done or the work will be completed. So the decision also taken by the PLC. That is the benefit or novelty of the PLC. Again, you need some explanation? I will explain you. See, suppose I want to put off and on this light, okay, light source, and it is through, suppose, connected through the panel HMI. Then I will able to put on or off only one light. But suppose if I want to put multiple lights with some program, like, right, like for example, after putting on this first light, after 2 minutes the second light should on, after that, after 1 minute third light should on. So this is a different program is required, so that after pressing only one button, first this light will on, after 2 minutes second light, after next minute third light, and so on, based on my program. So if I want to operate everything based with the only one key, then in that case PLC can be used. Again, I will give you one example to make you understand about this. Make the decision, how it will make the decision. Sometime what happen, you have to control the temperature, maintain the temperature. So if you are operating through the PLC and you need to maintain the temperature at suppose 100 degrees centigrade. So when temperature is increasing slowly, so heater will on, and when it reaches to 100 degrees, and then when it reaches to a safety band, for example safety band is 0.5, so when it reaches to 100.5, immediately the heating will stop and cooling will start. Again it works on requirement of the machine, but normally either heating will stop or cooling will start, so that temperature will again reduce from 100.5 to 100, and again it will reach to 0.5 degrees band, safety band, so it will reach up to 99.5. Once 99.5 is reached, again the decision is taken to increase the heater, and then again the temperature will increase up to the 100 degrees centigrade. So temperature data is continuously monitored, analyzed, and then decision is taken whether heating should continue or heating should stop, or after stopping the heating whether cooling should start. This all is done with the PLC. Hope you are getting my point. So the decision also taken by the PLC. This is what information or message I need to convey from this slide. Hope you understood this point, right? So now what I want to discuss is the benefit of a PLC. The benefit is it work with the HMI, of course, but it is taking the real-time data, means actual online continuously it is taking the data. Now in HMI what happened, it is just displaying the data, right? Here what happened, it is continuously taking the real-time data. These operators interface can be simple displays with a text readout and keypad, or large touchscreen pads, more similar to consumer electronics, but either way they enable users to review and input information to the PLC in a real time. So the point here is real time continuously data is taken and collected in the PLC, stored in the PLC. It is simple, it is given here, like it is a text readout or keypad or like large touchscreen panels PLC will have. The PLC receives information from connected sensors or input devices, processes the data and triggers the output based on the pre-programmed parameters. So same thing I was telling you when I gave the example of a temperature, maintaining the temperature of the reaction, correct? So PLC, what happened? It receives the information from the connected sensors. So here I gave the example of a temperature, for example. So that temperature information, what is the temperature? That is continuously information is taken from the temperature sensors. Then that data is processed. So yes, the temperature is increasing. Okay, so they will process. PLC will process. Okay, 20 degrees, 22 degrees, 30 degrees, 35, 30, 40, 45. So it will process the data. And once my pre-programmed parameter is set at 100 degree or maintained at 100 degrees centigrade. So what happened? Based on that, it will trigger the output. Then it will trigger the command to run or to stop the heating or to run the cooling. So this is the meaning of these three lines. Hope you are getting my point. I made this in a simple, easy to understand language. Okay. Depending on the input and outputs, a PLC can monitor and record runtime data such as machine productivity or operating temperature, automatically start and stop processes, generate alarms if a machine malfunctions, and more programmable logic controllers are flexible and robust control solutions adaptable to almost any application. So what happened here, I'm just reading it so that you should not only listen, and you should not only, consider that, okay, we will take the training material and we will go through that, because I am discussing along with this. So I always suggest that I will share you the training presentation, but whatever I am discussing, it is only in the video. So you go through this if you have any question. So the point is, PLC is, monitoring the real-time data it depends on requirement of the machine. Most of the machine will have the machine with respect to productivity information or operating conditions information or automatically start and stop functioning. So many parameters, and also some companies, some machines, they may require to give some alarms to the operators. Like in case of excursion in some parameters, there should be some alarm. So if there is excursion, automatically the program is there so that the output will be given in the form of alarms. So that all type of programs are made in the PLC. So as per our requirement, the logics are made and programs are created in the PLC. So it is more advanced version from HMI to PLC, right? PLC is in short more advanced version. Hope you are getting my point, right? The PLC CPU stores and processes program data, correct? I told you that it takes the data, then it stores it. That means PLC is having a storage, right? It stores and it processes the data, that okay, what type of data is there, means analyze the data. But input output modules connect the PLC to the rest of the machine. These IO modules are what provide information to CPU and trigger specific results. So what happened? Input output modules are there. They collect the input module will collect the data. PLC will take the data, then analyze the data, or here I have written the word is analyze or maybe process the data. Okay, here I use the word process data. So collect the data, then PLC will process the data, and then based on the program and based on the value information received from the process data, the output function will be worked. So that way PLC functions. I am making in a simple language, easy to understand language, but still if you have any questions, so I am with you. Okay. Now I was telling about the this one IO, right? Input output, right? So input output can be either analog or digital. So I'm just these are the words of IT. I understand. Please be with me. Sorry, but these words I could not change it, so I need to keep the same words. and this normally wordings will be available in the during discussion with IT. So what happened, see, input and output, right? Input output wordings is very simple. For easy understand, I will again go through the last slide. I will just show you one, just to make you aware about the input output, right? What is the mean by input and output? Just a minute, the slide will take some time, 5 to 10 seconds to keep to display at your end. So if you can see the earlier slide where input and output devices are presented, so you can see a simple example like input device means in the system what are the sources of inputting the data, like the keyboard, mouse, or camera data which is putting in the system, it is the input. Output means maybe the printer from where the data is getting outside. So this is the output. This is a simple meaning of the input and output, right? So similar way in PLC, what happened, there are input output devices, they may be analog or digital. Don't worry, I am just going through that, I will explain you, don't worry about that, everything I will be with you, don't worry. Input devices means what? Now here I give the simple example of computer, right? Input and output. But in our case in PLC, input means what? From where the data will be entered, right? So in our case, in case of PLC, the input will be like sensors, switches, meters, these are the example of input devices. And output means relay or lights or valves or drives, because what happened, based on the input value the relay will work, or lights will be put on or off, light may be of alarms also, valves will be operated, or the drives will be function with the speed, high speed or low speed. So that way it will be work as a output. You got my point? Hope I am making it simple language, right? So here in case the PLC is getting the information from input devices, for example the sensors, switches and meters and all, correct? Then it analyzes the data, based on that whatever the program is made, based on that some output will be done. So the output will be made in the form of relays, lights, valves and drives. Hope you are getting my point. Drive means, for example, drive means high frequency drives, right? That way. Users can mix and match a PLC's IO means input output, in order to get the right configuration of their application. So what is the purpose of the PLC? What is the actual requirement of the PLC? Based on that, the input and output can be used as a mix and match. Means, for example, you may use the input device as a temperature, for example, temperature sensor, and output will be maybe light. So if temperature is increased, temperature excursion is there, temperature is more than the limit, then light will blow. Simple example I am giving you, that how the data is getting flow from input PLC and then output. Hope you are getting my point. So based on this, users can mix and match and prepare the PLC. Simple example I am putting here. Now the very important thing is URS in PLC. So URS means user requirement specification. You are all aware about this, about the URS and all, okay? So the point here is now, what points we should consider in the URS. So one is electrical capacity, that how much electrical connections or supply is required, how much electrical supply can be tolerated. Processing speed. So PLC's model, CPU speed, because what happened, this is nothing but a computer only. PLC is what? Computer, because it is collecting the data, analyzing it and then giving the output, right? So it is nothing but a computer. For me it is a computer, right? Computerized system. I call it as a computerized system. Instead of computer, I use the word computerized system or process control system, PCS. So what is the CPU speed? What is the PLC model? Because what happened, if the output we require on immediate basis, but if the speed is very low, then what happened? My purpose will not get solved. There will be temperature excursion, for example. There will be temperature excursion, and the alarm will not be given because there is a delay in the alarm, and due to that there may be some hazards may happen. I'm just giving some example to make you aware about the URS should be built in the PLC. Compatibility. It should be compatible to the whatever hardware you are using, correct? So it should be compatible. Temperature tolerance. So most of the PLCs, no, they work at 0 to 60 degrees temperature, but some reactions may take place at very high temperature. Very high temperature, maybe more than 150 degrees centigrade or 250 degrees centigrade. So the PLCs will not work at such a high temperature. So when you are having that facility, or you need to run the reactions at specific temperatures, higher temperatures or very low temperature, maybe like in case of some biological reactions and all, which may require very low extraction at very low temperature, or minus 40-50 degrees centigrade temperature. So you need to specify that in your URS that a PLC should tolerate this thing. Because if you use a normal PLC and use at a higher temperature, the all data will get corrupted. Hope you are getting my point. Memory. Now I told that the PLC collects the data, stores the data, analyzes the data, and based on that it gives some output. Simple words, right? So as it is storing the data, it will have the memory. The controller uses ROM, read-only memory, to store its operating system. So basically the controller of the PLC will have the ROM to store its operating system, and it will have the RAM, means read access memory, to execute its function. So ROM and RAM should be identified. How much ROM should be there, how much RAM should be there in my PLC, that should be identified as a part of a URS, in the URS only, so that it will have the information. Why I am discussing this thing? Because there is a one warning letter to one of the company that the inspector asked the question about how much data is stored in the PLC, and one of the operator was telling that the data up to 6 months it is stored. The manager told that no, data is not getting stored, it is just a display and it is working there, there is no storage. Then another IT person told that data is stored up to 1 year. But when the data from PLC was downloaded, the inspector come to know that the data for last 3 years was available in the PLC, and the company got the observation, and later it was turned to the warning letter. So basically, you know what my point is, that you have to identify at the start or the development stage only. So you have to specify this memory in the URS. This is very, very important. Hope you are with me, right? So this is the URS. The next URS what I want to touch upon is with respect to the connectivity. So again, I am just requesting you, please be with me, because what happened now, there will be some delay in the changing the slide, so please be with me. Maybe 10 seconds it may take it to, you know, change it. So connectivity, basically what happened, it is a computer, right? So make sure your PLC has enough input and output ports, and it is able to connect to the system requires. So what happened, it should have a proper connectivity. Otherwise what happened, why I am discussing this, because normally what happened, PLC is manufactured by some agency, and input output devices will be of a different, correct? Because input will be from the data, so it needs to be connected to the specific ports, through specific port to the PLC, and for output you need to connect the again output port to control some valves and all. So if that port are not suitable, the connectivity is not there, it is of no use, correct? So that is the reason you have to specify in the URL that what type of connectivity how many ports are required for input, how many ports are required for output, what type of ports are required, that has to be specified in the PLC. And also I just want to suggest that go for some more number of ports so that some port gets non-functional. Like suppose if you want to use some USB port to download the data, then request for more than one port, so that if one port is not functioning, you can download the data from the another port. So similar way you can request in the URS, that you can specify in the URS. Analog input output. Some models also have analog inputs and outputs that can control processes with continuous variables. So some models are there of PLC which have the you can say the analog inputs and outputs which can control the processes and continuous variables. But most of the some PLCs, they will have the only the discrete type of input and output. They don't have the analog type. If it is analog type, then they will able to operate multiple functions. But if it is a discrete type, discrete, okay, if they have the discrete type, then they can only perform some limited function like on and off, like that. So you can just suggest to have a analog input output. Okay, so these are some URS points you need to consider as a part of the PLC discussion. Okay, now we discuss about the so many benefits of a PLC, correct? You hope you are agree with me. There are so many benefits of PLC, no doubt. But that is the reason I am discussing about a drawback of the PLC, because I told that there are so many benefits of HMI, but there are some problem in the HMIs. Like it is not analyzing the data, it is not taking the decision. So we need to take a PLC so that we need not bother about that, right? So PLC is better than the HMI. Now in PLC we have very good advantages and all, but there are some drawbacks of a PLC. So what are the drawbacks of a PLC? That we will discuss here. PLCs have less capacity to handle extremely complex data or large number of processes that involve analog rather than discrete inputs. See, basically what happened, PLCs, as they have limited RAM and ROM, what happened, they can handle less data. They could not handle the more data or largely complex data. I will take example, then you will come to know better way. Okay, and they are more friendly with the discrete type of data, but most of the data are the analog data. For example, let us consider about the computerized system in a water system. Okay, the water system installed on computerized system installed on water system plant. I am taking example so that you will understand this scenario and correlate the thought. See, in water system what happened, there are so many operation parameters. Based on operation parameters, there are some controls. Some valves will open, some valves will off. There are separate cycles of sanitations, temperature controlling during sanitation. Simultaneously, during running operation also the velocity need to be maintained and all. So many parameters need to be maintained, right? At the same time, the continuous monitoring of level of the tank, then TOC or conductivity. So many parameters continuously we need to monitor. Now the point is this: if you put a thought on this, there are a lot of data continuously because water system is running continuously. So what happened, if you put a PLC may not able to handle all this extreme complex data. This is what the point is, because this is so much of complex. The routine water purification is separate, sanitation cycle is separate, then routine monitoring is separate, then alarms are separate. So all this controlling may not be possible, is not possible with the PLC. This is the drawback of a PLC. And as I told you that most of the operations are with the analog type of operations with so many variable parameters and not the discrete type of parameters. So discrete means just on and off type of parameter or simple operations. As manufacturing facilities become more integrated and involved, increasing number of them may shift towards a distributed control system or another alternative industrial control system. So what happens, as there are more complex or more integration are required due to the more and more controlling and operations modes and all, so we need to have some more alternative industrial control method. So this is again the drawback of a PLC, that it is not supporting the complex systems, right? The another drawback of a PLC is PLC from different manufacturers. What happen? Often they use some proprietary programming software. So what happen? I am manufacturing the PLC, then I will use my programming software. It may not be suitable for the other functioning or other uses. Okay, this is the this is the problem with this PLC. So this makes PLC programming interfaces less interoperable, means less compatible. Easy language is compatible than they might be, especially considering that their programming languages share common standards. So what happens, sometimes what happens, you are using the PLC but you need to put some more control, you need to make the connect to PLC to some other things, or you need to upgrade it. You may not able to upgrade because the proprietary programming software is with the manufacturer. So this is again the drawback. So manufacturer, when you run to the manufacturer will say, yes, you want to upgrade, we will only upgrade the PLC. So that way, you know, this is the one of the drawback, that it is the incompatibility with the other interfaces. So that is again one drawback for a PLC. The other drawback is, you know, what happened, as PLC is nothing but it's you know, electronic machine, right? Electronic component. So as there are the electromagnetic interferences in the machine, that electromagnetic interferences are adversely impacting on the PLCs, and due to that, so many times their electronic chips get malfunctions, or you can say the memory get corrupted or erased, or sometimes there will be some communication errors. So this is again one of the drawback of a PLC. Now you will tell me, you will ask me why it is there, because sometimes what happen, as the PLC is in the close vicinity of the machines and all, the electromagnetic interference plays very important role on the PLC life. So that way again it is a drawback of a PLC, right? Hope you are with me. So due to this drawback, we need to go further one advanced version or the next version, and that is the Scada. So you are with me, right? If you have any question, please put your question in the chat box. I will discuss all the questions. Okay. If you are not understanding this, you can again go through the same link. It is stored for some period in the YouTube. Same link, you can use it to go through again to make you understand. You can reduce the speed also, so that you can understand each slide carefully. So Scada means nothing but the supervisory control and data acquisition. So Scada is a computer-based system for gathering, analyzing real-time data to monitor and control equipment that deals with critical and time-sensitive material or events. Example I have given here is a Scada for pharmaceutical water system. So what happened? The real-time data is gathered, collected, monitored, trending, everything, alarm, and stored also. Everything is possible with the Scada. So this is the benefit of a Scada. So you can see now from our discussion from start till now that how the upgraded versions are there, HMI, then PLC, SCADA. Nowadays so many HMIs and PLC are synonymously used most of the time, but PLC is always the upgraded version because PLC is having a working on the basis of a logic. We call it as a programmable logic controller. But SCADA is something different, where there is a supervisory control on all the real-time data collected, analyzing it, monitoring, trending, giving the alarms. Everything is done in the system. So that is the SCADA. So the benefit here with the SCADA is you can see that there is no any limitation of the data. You can have a n number of data can be stored in the SCADA. Means the point is the storage capacity of a SCADA is far better than PLC. Second thing, multiple controlling, monitoring, then alarming, then recording, trending, so many operations can be done under one umbrella, that is the SCADA, supervisory control and data acquisition. So this is also the example of a process control system, PCS. A PLC, hope slide is visible to all of you. I request you, there are some couple of slides are there, so please bear with me. I will try to finish in maybe last of 5-6 minutes, but please bear with me. A PLC might also need to connect with other kinds of systems. For example, users might want to export application data recorded by PLC to the supervisory control and data acquisition system, which monitors multiple connected devices. So what happened? We need to the data recorded by the PLC may require to export. So that can be done in the SCADA. So data can be collected, but the data, if you want to export it and all, can be done with the SCADA. PLC offers a range of the ports and communication protocol to ensure that PLC can communicate with these other systems. So the PLC connected with the SCADA offers a range of the ports and communications protocol so that PLC can communicate. Communicate means PLC can take the input and give the programmed outputs on the other system. So that way they are connected through the SCADA. So SCADA is not the machine, it is also the combination of a different functionalities. So what are the components of SCADA then? If I am discussing about this, so what are the components of a SCADA? So the very first component is a sensors and actuators. Sensors, we all know about the sensor, right? Means sensors are, they collect the information, means input, collect the input information and transmit to the system is a sensor. Actuator means what? The output. Based on the data collected through the sensor, whatever output need to be given, that output is through the actuators. Hope you are getting my point. So this is what I have mentioned here. SCADA field controllers, these interface directly with sensors and actuators. They either directly interface with sensor to collect telemetry data, means collect the online or real data and forward for further action through the remote terminal units, RTU. PLCs interface with actuators to control industrial processes, usually based on current telemetry collected by RTU and the standards set for the process. These words are confusing, but the simple thing is sensors and actuators part of the SCADA. First component of a SCADA is the sensors and actuator. So simple meaning here is sensor is collecting the data and actuator means where it is giving the output, maybe working on the walls and all can be done with the actuator. And there are different type of SCADA field controllers. So one is interface directly with the sensors and actuators and another through the PLCs. So when they are direct, first part is they are directly interfacing with the sensors and actuators. So there what happened, the real-time data is collected and terminal units or RTU, remote terminal units. With the remote terminal units, it gives the it gives the signal to work the actuators. And second functioning is based on the PLC. So PLC will collect the data, analyze the data, and it will give the output through the actuator. So sometimes SCADA will work with the directly with the interface or through the PLC. Simple meaning of this slide. Okay. The next point is, what is the component? SCADA supervisory computer. This is the next component. These controls all SCADA processes and are used to gather data from field devices and to send commands to those devices to control the industrial processes. So basically, first we saw that sensors and actuators or real RTU, right? Now the second is, we need a computer, right, where it can be processed and collect the data and process the data. So it will require the supervisory computer. And the third component is HMI software. This provides a system that consolidates and presents data from SCADA field devices and enables operator to understand. So that means what? Screen. HMI software means what? Screen. Now don't get confused with the name here, HMI. Okay. So HMI software means nothing but a screen. So whatever the analysis and everything is done, it has to be displayed to the operator, right? So that is called a HMI software, which provides a system that consolidates and presents the data from SCADA field devices and enable operator to understand the things, and if required, modify the status. So if required, they can change the status. So these are the components of a SCADA systems. Hope you are clear with these components, right? And the last component of the SCADA is communication infrastructure. So this enables SCADA supervisory system to communicate with field devices and field controllers. Because what happened, information is taken, everything is done, but then it has to be the message should be given to the field controllers also, right? That they have to operate, correct? So this communication infrastructure is very, very important to communicate with the field devices. Devices means the sensors, and field controllers, where they are controlling the operations. The infrastructure enables SCADA system to collect the data from the field devices, means sensors. I am making easy language, okay? Field devices, for example, sensors, and control those devices. So these are the 4 components of a SCADA system. A basic, simple way to make you aware and make you understand. And next thing, I just want to share information that there is a YouTube membership program. In the in this training, there is one sign will be there, $sign. So many people click it and paid some fees, but please, this is a free learning platform, so don't pay the fees by clicking the $sign appearing near your comment section. So there is a YouTube membership program. It is through the YouTube. So I have created the 3 membership program: GMP, CGMP, and Advanced GMP. You can just go through the YouTube. You put my name, Hitendra Kumar Shah. When you go, you will find that there are 3 icons, and there is one is a join. So if you join it with some very small fees, you will be the member for a GMP. The second is a CGMP, and third is the Advanced GMP, and there are a lot of benefits under this. So this program is developed with the YouTube, so I am sharing with you. Okay. And finally, I just want to share my vote of thanks to all of you, that thank you so much for your kind attendance, and be patient with the discussion we had on the HMI, PLC, and SCADA. I specifically prepared for the people who want to understand about the basics about HMI, PLC, and SCADA, and how they are more beneficial for the industry. Because 2 weeks before, we had a training on Pharma 4.0. So many people raised the question to me that discuss with me about the please put some more videos on the automations and all. So I put this video and I put this lecture on the PLC, HMI, and SCADA. Okay, thank you so much. Please share this link to all of you so that they also can benefit with this training. So now I just want to go through the questions. Okay, what type of challenge test to be done in qualification oblique CSV activities of HMI, PLC and SCADA? Pharma Dreamers Arijit is asking this question. See, there are so many tests are there for this specific to this HMI, PLCs and SCADA. So there are, you know, the black box testing, white box testings are there and all. So if you are interested, I suggest I will have another session on that, because there are so many different tests are there about black box testing, white box testing, and again so many loop testings are also there and all. So I will take a separate session on that, because it's a big topic on that. Okay, I think there is no any much question here. Okay, so I think we can now close this training session. Put the comment on the chat box. You need to subscribe, and then only you will able to put the comment in the chat box. So please subscribe this YouTube channel. I request all of you, so that, you know, I will have more connects with good people like you and technical people like you. Thank you so much. I am now stopping the today's training session, right? Thank you so much, and ensure the all-time compliance. Thank you.